Brazil, and Venezuela. Drilling a safe, deep-water well can take years of planning and preparation. After identifying potential oil and natural gas reservoirs beneath the seafloor using seismic technology, a drill site is selected. Shell geoscientists choose the drill site location on the seafloor based upon the safest well path that will encounter the targeted oil and natural gas. For an exploratory well, in water depths up to 9,000 feet deep, this seafloor location is generally directly above the reservoir. A drilling rig is required to drill a well. In deep water, the rig may be on one of three vessels: a drill ship, a semi-submersible vessel, or it may be part of a floating production platform. All rigs have a hoisting system to raise and lower the drill pipe and tools needed to drill the well, a blowout preventer or BOP stack, and a pumping system to circulate fluids in and out of the well while drilling. It's time to drill the hole or well bore using a drill bit. This initial step is called spudding in the well. The shallow sediments just below the seafloor are often very soft and loose. To keep the well from caving in and carry the weight of the wellhead, a large diameter base pipe or casing is drilled or jetted into place. The base pipe is assembled at the rig floor, and a drill bit connected to a drill pipe is run through the inside to the bottom of the casing. The entire assembly is lowered to the seafloor by the rig hoist. At the seafloor, the driller spuds the assembly into the seafloor sediments, then turns on the pump. Water or a drill fluid is used to jet the pipe into place until the wellhead is just above the seafloor. With the base pipe and wellhead at the right depth, the driller will release the bit and drill string from the jet pipe and drill ahead. While the well bore is being drilled, mud is pumped from the surface down through the inside of the drill pipe. The mud passes through the jets in the drill bit and travels back to the seafloor through the space between the drill bit and the walls of the hole. Drilling mud is used to 1. Lift rock cuttings from the hole, 2. Keep the drill bit cool and lubricated, and 3. Fill the well bore with fluid to equalize pressure and prevent water or other fluids in underground formations from flowing into the well bore during drilling. The mud is an environmentally friendly water-based mixture of clay for thickness and fine ground rock or barite for weight. At the planned depth, the driller will stop drilling and pull the bit out of the hole. A smaller pipe or casing string is then screwed together, connected to the drill pipe, and run down to the seafloor and into the well. To permanently secure the casing in place, cement, followed by mud, is then pumped down the inside of the drill pipe. To separate the cement from the mud, a cementing plug is used. The plug is pushed by the mud to ensure the cement is placed outside of the casing, filling the annular space between the casing and the open hole wall. On some locations, a second surface casing is needed, thus the well is drilled even deeper. In this second surface casing interval, the well is cemented using a second smaller casing string, repeating the same process used in the last hole section. At this point in the well, the pressure in the deeper rock may be too high to continue with the simple water-based clay mud, or there may be the potential to encounter oil or gas. Before drilling below this point, a blowout preventer with a riser will be installed at the seafloor. The BOP stack is a massive system of valves and rams that protect the rig and environment from oil and gas flows should the weight of the drilling mud be too low. The BOP stack is connected to a pipe called a riser. The riser connects the rig to the well and allows us to circulate the drilling fluid and rock cuttings all the way back to the rig on the surface. The BOP stack is fully tested before we drill further. Drilling now resumes with the drill bit and drill pipe always operating through the BOP stack. Just as we did further up the hole, casing strings are run and cemented in place when needed to cover up the open hole sections. When the oil and gas zones targeted by the geologists are reached and the presence of an oil or gas zone is proven, A final casing string may be installed if the seafloor location is favorable for future development. This final casing string allows for the future safe production of the oil
and the sea floor. To start an offshore well, a thick-walled, large-diameter hollow tube called a conductor is embedded in the sea floor, with the aid of a bit that jets away the sediment with high-pressure seawater. When the conductor has penetrated about 250 feet, the jet bit is retrieved and a drill bit introduced. The cuttings are just washed to the top of the well by seawater pumped through the bit. A second run of conductor is now lowered into the hole. At the bottom of the conductor is a guide shoe that stops the conductor snagging on the well bore. Above the shoe is a flap valve called a float collar. A cementing tool is connected to the top of the conductor. A plug that pushes the seawater out is driven downwards by high-pressure cement that fills the conductor. On reaching the float collar, this plug is ruptured, and cement flows out of the bottom of the conductor and up the annular space between the wellbore and the conductor. The cement plug tool is removed, and when the cement has set, drilling continues with a smaller diameter bit, penetrating the cement plugs and float collar and into fresh rock. After a suitable depth has been drilled, the drill string is removed. Then steel tubing, known as casing, is lowered into the hole and cemented in place. This first casing run has an attached wellhead. A blowout preventer, BOP, a robust set of valves that can shut in the well even if the drill string is down the hole, is then lowered and locked onto the wellhead. The BOP is connected to the sea surface by large diameter tubing known as a riser, which allows drilling fluids to be returned to the surface. From this point onwards, the drilling procedures are similar to those used to drill an onshore well. With the riser in place, seawater is replaced by a special fluid known as drilling mud that is pumped down the string and exits through ports in the bit. The mud not only cools the bit, but also clears the cuttings from the hole. The cuttings are captured at surface and examined by geologists to characterize the rock types that are being penetrated. As drilling continues, sets of decreasing diameter bits and casing runs are used as the well penetrates deeper into the rock. Each run of casing is cemented in place to provide integrity, a sealed system from top to bottom. The density of the mud is controlled by the mud engineer, adding dense minerals when needed. The aim is to produce a column of dense mud which exerts sufficient pressure in the well to counteract pressure from fluids encountered in the rock. This combination of the dense mud column, contained in properly cemented casing, aims to control pressures in the well. The BOP provides a further level of security. When the well penetrates a potential reservoir rock, the oil or gas may be detected by analyzing the drilling cuttings for traces of gas and/or oil. At this stage, it is essential to gather as much information as possible about the reservoir. Two methods provide most of the information. In the first, the drill bit is replaced with a diamond-studded coring bit at the bottom of a core barrel. This can cut a complete section of the reservoir rock and return it to surface for detailed analysis. In the second stage, coring may be replaced or complemented by running a suite of geophysical logging tools, which are run on electric wire line. These are instruments that can measure the physical properties of the rocks as they pass slowly through the well bore. When as much information as possible has been gathered from the reservoir, a decision is made on whether to complete the well for production, suspend efforts with the option to return to the well at a later date as more information on the reservoir becomes available, or to plug and abandon the well. If the well is seen to have production potential, the reservoir interval is lined with casing. The casing is then perforated to allow reservoir fluids to enter the well and travel up the installed completion production string to surface.